Hey guys, so I hope you are doing well there. So today I bring one more lecture on relational algebra. That is the lecture number 4, and we have covered 3 lectures on relational algebra, and all of them are very important. So guys, if you have not gone through them, then check the links in the description box below. And one important thing, that if you want to contribute towards this free sharing of knowledge, then do subscribe this channel and ask your friend to do the same. Okay, so share with your friends. So let's start today's class. So in the last lecture number 3, that is very important, because I have discussed about natural join, one of the frequently used operator in relational algebra, and today I will discuss 3 important operations. First one is union, second one is set difference, and the third one is set intersection. So guys, do concentrate on this lecture till the end. So union of two relations. I know that all of you have got this term union in your mathematics or in your Boolean algebra. Okay, everywhere you have seen this operator to be used. Okay, so union means what? We try to combine two sets. Okay, so I will go through examples. I will take some examples to illustrate this operator. Okay, so I have considered two relations, R and S, and R is from the schema capital R and S is from the schema capital S. Now R relation have two attributes, A and B, same in the case of S also. The values for the R are alpha 1, alpha 2, beta 1, and values for S are alpha 2, beta 3. The union operation will be denoted by what? This symbol, and you all know this symbol. This is for union. So R union S will be what? We will combine the elements of R and S. Only one thing you have to notice, that whatever the common values are there, they will appear only once. What I have said, whatever the tuple they are common in both the relations, they will appear just once, not twice. Okay, so alpha 1, beta, alpha 2, beta 1. So alpha 1 will come here, alpha 2 will also come, beta 1 also come. So alpha 2 you have seen also present in S. So we have already covered here, so don't need to write twice. Now beta t is different, so beta t will come here. So this is our R union S, that is alpha 1, alpha 2, beta 1, beta t. Got it? So actually in exam you will find questions where you need to use union operators. Okay, and I have seen from my students doubts that they frequently have confused about where to use this union operator. Okay, see one example. If question asks like that, find the name of instructors and students. So what student confused that, sir? This is n in the question it is asked with n, and so looking at this n, they go for using intersection. Guys, that is wrong. Okay, so what the question is asking is the name of instructors and students. They are not asking that find the names which are common in instructor and student. They are not asking that. They are asking the name of instructor as well as the name of the student. So that's why n is used here. Okay, so what will be the relational algebra equation for that? So of course we are concentrating on what? Name, and name is what here? Name is attribute. So what operator we will use here? Of course project operator we will use, that is this one. So phi, but there is project operator on instructor for name. Union, project operator on student with respect to name. So first one will give you all the names of instructor from the instructor table, and second one also give you the names of the students from the student. Then we'll take the union, we'll take all the values from here also, and only the values or tuples which are repeating, they will be taken only once. So ultimately we'll get the names of the instructors and students. Got it? So any confusion, to ask me through comment. Okay, so next operator is difference, set difference. By set difference operation in set theory, suppose we have a set A, we have a set B. It is denoted by, of course, the minus symbol. What does it mean? This means A minus B will contain only those elements of A which are not present in B. Got it? You already know about that. But same thing will be happening in relational algebra also. You have seen these two relations, R and S. So if I want to find out R minus S from here, so what does it will contain? It will contain only those values of R. What I have said? Those values of R which are not present in S. Because if some values of S will be there in R, then that will be what? Cut it out. Because means we are not going to take them. So in this case, R is AB, alpha 1, alpha 2, beta 1. S is alpha 2, beta 3. So which tuple is common here? You have seen alpha 2 is appearing in both cases. So we are not going to take it. So we are going to take only these values, alpha 1 and beta 1. So R minus S is alpha 1, beta 1. Got it? So they are the values present in R, but they are not sorry, present in S. Clear? So that is our set difference. And the question, the practical question that will appear in your examination will be like that. Find the department which do not hire instructors. You see, in our previous lecture, I have given examples on two tables. Sorry. That is department table, and that is another one is instructor table. Okay, so these are very commonly used tables by many authors in standard textbooks to illustrate these things. Okay, so we need to find out those departments which do not hire any instructor. Means in those departments you will not find any instructor. That's what it means to say. So of course here also we are going to use what? Project operator. Okay, so pi department name from the department. So that will give all the department names. From means this side will give you the names of all the department. Now we don't need those departments which contain some instructors. So how to find it? So pi department name from instructor. So from this department we got all the department names, and from here we got those departments which have some instructor. Now use minus operator, or means set difference operator. Then this will give you names of those department from the department where this one not present. Means the instructors in the department, means those departments which contain instructor will be not present. So ultimately give you the answer for these equations, means find the department which do not hire any instructor. Is this clear? Very good. If it is clear, if it is not clear, then do ask me through comment where you are finding it difficult to understand. So set difference operator is clear. Then coming to the next one, that is set intersection. So from the term intersection, what we mean? The common thing. Now I am talking about the common thing. Means two sets are there, A and B. If I use Venn diagram to represent this set A, and suppose if I use this circle to denote B, then this portion will of course denote the intersection, and this is denoted by this symbol. Okay, this symbol. So those things, those tuples which are common in both the sets. Similarly here, intersection of two relations R and S will contain only those tuples which are present in both the relations. Suppose in this case R, this relations I am taking, and S, this relations I am taking. So of course you will see that this alpha 2 present in both cases, R and S also. So R intersection S will be what? AB alpha 2. So that will be the result. Got it? Do not confuse intersection with union here, because here it seems to be same, but the only difference you will find through practical examples. Why I am repeating the same thing again? Because I have seen from my experience with communication with my students, from their doubts arise. Okay, So next practical example is that find the instructors who are also students. Means you need to find out those instructors, okay, which are means studying some course in some university also. Okay, you frequently see that some students are also instructor in some different colleges like that. Okay, so we need to find out the instructors who are also students. So what again, we are concentrating on the project operator because the attribute is concerned here. So this is the name. So I want to first retrieve the names of the instructors. So that will be possible through this equation. Means phi or project operator on instructor with respect to name. This will give you the names. Then students, again we need to find out the students names also. If those names will be common, then that will be the result. Okay, so project on students with respect to name, this will give all the names of the students and this will give all the names of the instructors, and when we take intersection, this will give you the common things, this common names, and obviously common names will be our result, means those instructors who are also student. So this is clear to you? Okay, so guys, I hope you have got all the three operators today I discuss, and these are very important things. Okay, so do not confuse with anyone. Any confusion, ask me. Okay, and go through some practical examples. So guys, if you have enjoyed this lecture, then don't delay to press that like button. Okay, you will see there. So guys, we'll meet in the next lecture. Till then, take care. Bye bye.